If you've worked with JavaScript before, you might think of it as just a front-end technology, a way to add interactivity to web applications, to add features like button clicks and drop-downs. But that's not all JavaScript can do. With Node.js, you can use your JavaScript skills for more. Everything from building command line tools to creating servers to interacting with the file system. Since Node.js was released in 2009, companies like PayPal, Netflix, and Microsoft has used it as a way to build scalable, event-driven applications. Node.js is everywhere. Right now is the best time to become a full-stack JavaScript developer with Node.js. Node.js Essential Training will provide you with an in-depth introduction to Node.js. But there are a couple things that you may want to be familiar with before getting started. First of all, Node.js is JavaScript, so you need to be familiar with JavaScript in order to work with Node.js successfully. If you'd like to learn about JavaScript, check out JavaScript Essential Training with Morten Rand Hendrickson. Finally, since we're dealing with server-side JavaScript here, some working knowledge of the command line would be helpful. If you do not feel comfortable with the command line, you can get up to speed with Unix for Mac OS X users with Kevin Skoglund. If you feel comfortable with JavaScript and you know the basics of the command line, then you're ready for Node.js. Node.js can feel like a brand new technology, but it's been around for about a decade, and is one of the most powerful JavaScript tools available. Node.js was created by Ryan Dahl in 2009 as a JavaScript runtime based on Chrome's V8 engine. In 2011, NPM version 1 was released to allow for sharing of open source Node libraries. This marked a huge shift in the way that code was shared and maintained, and it started to cement Node.js as a huge player in the ecosystem. After some infighting in the community about implementation and project management, the Node.js Foundation was formed in 2015. The foundation is made up of several large companies, including IBM, Microsoft, PayPal, and Groupon. It's referred to as a collaborative project at the Linux Foundation. You can find the Node.js Foundation on GitHub, and you can also find the Node.js project itself. It's an open source project on GitHub. You can view the source here. Today, the Node.js community is thriving with numerous conferences and events internationally and wide uses across all industries. I'm going to demonstrate how Node.js works and why it is so fast by taking a look at two restaurants. The first restaurant is Apache Steaks and Chops. It is a big, nice, fancy restaurant. In this restaurant, every new guest represents a new user, and making an order is like making a request. If I place an order for a salad, the manager will need to hire a new waiter to take care of me. In this restaurant, our waiter represents a thread. We are going to have our own waiter, our own thread, and they will handle all of our orders. This is similar to how Apache works. Every request is single-threaded. After placing the order, the waiter will take the order to the kitchen and give it to the chef. And now the waiter just waits. He won't do anything else until the chef is finished making the food. I would like to order a glass of water, but I can't order anything until the chef finishes making that salad. The chef is blocking me from being able to simply order a glass of water. In this analogy, the chef represents the file system or a data store. In Apache, the single thread waits for the file system to finish reading files before it can do anything else. We refer to this as blocking. Finally, my salad is ready. My waiter brings me the food, I can order my glass of water, and my waiter also brings me that too. My request has been served, and now the manager is firing my waiter because they are not needed anymore. Now, when this restaurant gets busy for dinner service, every guest has their own waiter, which is pretty nice. That is pretty good service. But the waiters are mostly hanging around the kitchen and waiting for the chef to make the food. If this restaurant gets really popular, it requires a lot of space to expand because more guests means more waiters. Now let's take a look at this other cafe, Chez Node. At this cafe, there is only one waiter because Node.js is single-threaded. Here, we can order some crepes. We can see that our waiter places the order for the food, then moves on to take an order from another new table. This single thread services all of the restaurant guests. That is pretty cool. When my crepes are ready, the chef rings a bell and our waiter goes and gets the crepes and delivers them to me. He then proceeds to take another order from a new table. When their food is ready, the waiter will bring it to them as soon as he can. We can say that this waiter behaves asynchronously. Everything this waiter needs to do represents a new event. A new table, placing orders, delivering orders. These are all events, and they will get handled in the order that they are raised. Our waiter does not wait. There is no blocking. Our single waiter is busy, but he is killing it because he can multitask. This is what it means when we say non-blocking event-driven I/O. We have a single thread that will respond to events in the order that they are raised. This thread behaves asynchronously because it does not have to wait for resources to finish doing what they're doing before our thread can do anything else. If this cafe gets popular, we can simply franchise it. Shea Node can easily be expanded by simply duplicating or forking the restaurant into a neighboring space. And this is precisely how we host Node.js applications in the cloud. Now remember, Node.js is single-threaded. All of the users are sharing the same thread. Events are raised and recorded in an event queue, and then handled in the order that they were raised. Node.js is asynchronous, which means that it can do more than one thing at a time. You can take this course with the text editor of your choice. Node.js simply runs JavaScript files, which are text. So if you already have a favorite IDE for JavaScript, feel free to use that. If you want to follow along in the same IDE that I'm using, you can download Visual Studio Code from code.visualstudio.com. This page will also automatically detect your platform and select the appropriate installer. So you can choose that installer or choose from any of these installers and simply run them. Once you have VS Code installed, you can open it. It'll bring you to this nice little welcome tab. And on the left here, you'll see a menu. The first icon is for your files. To select a working folder, you can click on the Open Folder button, and you can navigate to choose your folder. I'm using the exercise files under Chapter 4, Chapter 4.3. I can select the Start folder, and then I will have access to all of these files within our file menu. So a couple other features of the VS Code editor that we'll be using today is we'll be automatically hiding and collapsing this file menu. You can do so by clicking on the icon here or selecting Control B. So Control B also toggles that. We're also going to be using the integrated terminal. So you can, if you're following along with us, choose to use the regular terminal, but VS Code integrates the terminal right on the screen. So I can access that simply by selecting Terminal and then saying New Terminal. I can also close this terminal and kill the session by clicking the trash can, or keep the session open by clicking on the X. I'm going to be using a shortcut key for that as well. It is Control Backtick. So Control Backtick will allow me to toggle back and forth to my terminal. If you want your screen to look exactly like mine, I am using the View, Appearance, Zen Mode, and View, Appearance, Zen Mode, Toggle Centered layout. You don't have to follow along with Zen Mode. Zen Mode is just a little bit better for presentation because it gives me the full screen. So that's it. You can follow along with your own text editor, but if you choose to use VS Code in the integrated terminal, you can do that as well. The easiest way to get Node.js is to install it from the website. So I can go to the browser and go to nodejs.org. And right here on the Node.js org homepage, your operating system is detected, and the two versions of Node.js that you might want to install are selected for you. So we have 14.6.1, that's the current stable version, and then we have 16.0.0, and this is the Node.js with the latest features. I'm going to go ahead and install 16.0.0 by clicking on it, and then downloading the package. So I can see down here that we have the package downloaded. I will show that in the Finder. And then from the Finder, I can go ahead and double click on the package itself, and that will open up the installer. All I have to do is follow the instructions. We can see here that it's going to install Node.js version 16 and NPM version 7. That's fine. So we'll continue. We will agree to the license agreement. So then I will go ahead and click the install button and enter my password, and we will install Node.js. So there we go. Now I can actually come over here to my terminal that I have open. On any terminal, you can check the current version of Node.js that's installed by typing node-v. And that will give us the current version of Node that's installed. So we can see that we have version 16.0.0. Now we're ready for the rest of the class. Now it's time to create our first Node.js file. I'm working within the exercise folders under Chapter 3, but you can really create this file within any folder on your computer. I'm just going to come over here to the Explorer and click the plus file icon next to the Start folder, and I'm going to call this file firstfile.js. And within our first file, you could probably guess what's going to happen next because this is a computer science class and this is our first file. We're just going to go ahead and log hello world to the console. So we'll go ahead and save this. And as you can see, we've typed one line of JavaScript code into this JavaScript file. It's time to run it. So I'm going to go ahead and open up the terminal. Now I want to make sure that I'm in the same folder as my file. So I type a ls, and we can see that the first file is within this start folder. So to run this file, all we have to do is type node firstfile.js, and we can see hello world is printed on the console. So as you can see, this is just a JavaScript file. which means we can add JavaScript code to this file. I can create a variable called hello, and we'll do a message hello world from Node.js, and I can go ahead and log the variable in the console instead. So now I can come down here to the terminal, and I can also run this file again by typing node first file. But this time I'm going to leave off the .js extension. Because Node assumes that it's a JavaScript file that we're running, we don't need to add that extension there. So we can see our message logged to the console, hello world from Node.js. So within Node.js, we can create JavaScript files and run them. But what exactly is going on here? On line 3, we are logging hello to the console. The console object is actually a part of the global object. I could prefix this with global dot. And when we run global dot console log, we're going to get the same output. So if I come down here and save this, and node first file again, we can see hello world from Node.js. So everything on the global object is available to us globally. This means we can use any of the objects or values that are available to us on the global object within our JavaScript files. So the global object contains all of the objects, values, and methods that we can use in a Node.js file without having to import any functionality. If I come over here to the Node.js documentation, we can take a look at the global object, and these are all of the values and objects and functions that are available to us globally to use within any JavaScript file. In this last lesson, we took a look at the console object. In the last lesson, we created and ran our first Node.js file. We also learned about the global, which contains the functionality that is available to us within a Node.js file without having to include or require any other modules. In this lesson, we're going to continue to explore this global object. I'm going to come over here into the file folder and add a new file called global.js. And another thing that's available to us globally is the name of the current file, as well as the full path to the directory that we're currently using. So console log __ dir name is going to give us our directory name, and console log __ file name is going to give us the full name and path to the current file. So I'm going to go ahead and open up the terminal and run this file by typing node global. And when we run this, we can see log to the console, the full path to the directory that we are using, as well as the full path to the directory, including the file name of the current file that we've run, global.js. Node.js also comes with some tools that will allow us to edit and manipulate file paths, but we have to actually load these tools because they come in a separate module. And that's okay, because also available globally to us is the CommonJS module pattern. This pattern is how we import other code into our files. There's a function called require, and then there's an object called exports later. But for now, let's take a look at how we can import other modules. So the require function can be used to load external modules, which are other JavaScript files containing code. We can either load modules that have shipped with our installation of Node.js, or modules that we install with npm, or other modules that we create, just other Node.js files in our directory structure. Right now, let's look at the path module. So the path module is one of those modules that ships with Node.js, and it gives us tools that we can use to help us work with path strings. So I'm going to create a variable, constant called path, and we will load the path module into that variable. So now that we have the path module loaded in this file, we can use the base name function to pluck the file name only from the global file name variable. So I'll go ahead and log with a template string. I'm going to go ahead and use backticks. Those aren't single quotes, that's the backtick character. The file name is, and I can go ahead and add a variable to this template string. We'll use the path module, and on the path module, there's a function called base name. And we can send the __ file name value to the base name function, and it should pluck the file name. So let's go ahead and come down to the terminal here and run our file by typing node global. And we see that using the path.basename function has allowed us to pluck the file name from the full path. So every Node.js file that we create is referred to as a module. It contains its own code. And when we want to load other modules, we must use the require function that is available to us on the global object. Another important object that's available to us globally is the process object. So within my files, I'm going to create a new file, and we're going to call it the global process.js. So the process object can be accessed globally, and it contains information about the current process as well as tools to allow us to interact with that process. So for instance, we can use the process object to get the process ID, or we can also use the process object to get the current version of Node.js that's being used to run the process, process.versions.node. And I can go ahead and open up my terminal and run this file by typing node global process. And we can see the process ID as well as the version of Node.js that's being used to run this process. With the process object, we can get environment information, read environment variables, communicate with the terminal or parent processes through standard input and standard output. We can also use it to exit the current process. One of the things we can do with the process object is collect information from the terminal when we load the application. There's a variable called process.argv. And I'll go ahead and delete what we have here and log the process.argv. So these are the argument variables that are sent to the process when we run it. So I'm going to come down here to the terminal and I will run my global process again by running the command node global process. So as we can see here, the process.argv value is an array. It contains everything that we typed to run the process. The first command that we typed to run this process was node. So as you can see, we see the full path to where that node process lives. That's where we've executed Node.js from. The second argument is a path to the current module that we're using. So as you can see, we have the full path to the global process. So anything we type when we run a node file gets added to this process.argv array. For instance, I could add my name, and we notice that the array gets a little bit longer, and Alex Banks is the next thing that we see. Now, because process.argv is an array, we can work with it the same way we'd work with arrays. For instance, I could use array destructuring. If I wanted to get my first name and my last name, I really don't care about the first two values in the array, but I can set the third value in our arguments array to first name and the fourth value to last name. And here we've just destructured the argv array. And I can say, your name is first name, last name. Great. So we'll go ahead and save this and come down to the terminal and run it by typing node global. So we have a lot of stuff here on the terminal, so I'm going to clear the terminal by typing clear. If you're using DOS, the CLS command will work. So now I'm going to type node global process, Alex Banks, and you can see that we've destructured my name from the array. So we can use the process.argv array to send arguments to our Node.js module when we run it. So typically we wouldn't just put our name in all willy-nilly like we just did here. What we actually want to do is provide flags so that we know what type of variables are being passed. So I can say node global process, and we can send a user flag. This time the user's name will be Ned, and a greeting flag. And in the greeting flag, we'll go ahead and add Heidi Ho. Heidi Ho. So what we're doing here is we are providing flags to let us know what variables we are passing. You'll also notice that we used quotation marks around Heidi Ho because we don't want the space between Heidi and Ho to create another value within that process.argv array. Using quotation marks will treat that entire value as one string. So if I run this, it says your name is user Ned because we haven't changed the code up here. So let me come back up in here and I will get rid of the code that we currently have. So let's say I wanted to grab the greeting. I could set a variable, greeting, and we could use a grab function. Say we created a function, and within this function, we can just send in the flag that we want to obtain the value for, greeting. So let's say we also wanted to find the user. We can also use a grab function and then send in our user flag. So remember, the process.argv is an array. What we want to do is find the index of -- user or find the index of -- greeting and then return the next value. So let's go ahead and build the grab function to do this. So we'll use an arrow function, and the arrow function will grab our flag that we send to it. That's the argument -- greeting or -- user. And what we're going to do is find the index after the flag using the process.argv array. And because it's an array, we can just use the JavaScript indexOf command, and we will search for the flag. That will give us the index of the flag. Since we want the value, we'll go ahead and add 1 to that, and that should give us the next index, which we can then use to return that value. So once we find the flag, we will increment the index 1 and then return the value. So now let's go ahead and see what we have. And we will use backticks to create a template string. So we'll go ahead and include our greeting value and then our user value. let's go ahead and save this, and we can come to the terminal and run the exact same command. I'm just going to push the up arrow to get it. And we can see that we're going to run node global process with the user Ned and the greeting hidely ho. And we see the greeting hidely ho. So if you're asking yourself why we used a function to grab the values of these arguments that we're passing in, this is because it will allow users to pass arguments in any particular order. Let's say if we added the greeting first. This time it'll be hello, and the user. This time that'll be Alex. Our application will still work because we're finding the index of the greeting and grabbing that value, and the index of the user and grabbing that value. So the process object is an important object that contains information about the current process. And in this example, we use the process.argv array to pass arguments to our Node.js module when we run the process. In the next couple of lessons, we're going to build a simple question and answer app that runs in the terminal. So I'm going to start off by creating a new file in our folder called questions.js. Another feature of the process object is standard input and standard output. These two objects offer us a way to communicate with this process while it's running. For now, we're just going to use these objects to read and write data from the terminal. And in this lesson, we're just going to be taking a look at process.studout. So process.standardOutput is a writable stream, and it implements a write method. So we can use this write method to send data out of our program. In this case, we can actually write a string to the terminal. So I'll do hello space, and then I'll do another call to process.studout.write world, and we'll add a couple of new lines in there as well. So I'm going to go ahead and open our terminal and run this so we can take a look at the output, node questions. And when we take a look at the output, we see hello world is printed with 3 extra new lines. So what you might have noticed is we've already been using standard output. However, console log adds a new line for each message, so every log will appear on its own line. The process standard output.write method gives us a little bit more control over the string. So you'll notice that even though I made 2 calls to studout.write, we are still only seeing hello world printed on 1 line. So let's go ahead and use the standard output object to ask some questions. So the first thing I'm going to do is delete what we have here. I'm also going to collapse the terminal. And we're going to create some questions. And these questions will be an array of strings. What is your name? What would you rather be doing? And what is your preferred programming language? We're also going to create a function that we can use to ask a question. So we can also create an ask function that we can use to ask questions. Now within this ask function, we'll take in an argument, which will be the index of the question that we want to ask. And if no argument is sent, that index will be 0. So we can use process.standardoutput.write. I'll use backtick so we can use a template string. We'll add a couple of new lines to this template string, and we will ask a question using the questions array. And we will ask the question at the index. So if I is 0, we're going to ask the first question, what is your name? If I is 2, we're going to ask the last question in this array, what is your preferred programming language? We're also going to do another call to studout.write so that we can prompt the user for an answer. And we'll just put a little prompt there. Great. So now let's go ahead and use this. Let's ask a question. So I'll go ahead and invoke the ask function, and then we can go ahead and take a look at the terminal and run our app. So you'll notice that we have written to the terminal 3 new lines. That's the white space that we see before the question, what is your name? And our little prompt caret. And then the program exits. Notice that using standard output write kind of screwed up the terminal. We actually put the next terminal start prompt here after our standard output write. So that's important to remember that we're in control over new lines if we want to use them when we're using standard output write. Now, the reason that the program exits here is because this Node.js module, along with every module we've built thus far, is running synchronously. What that means is we declare the questions array, we declare a function for asking the question, and then once we ask the question, Node.js sees that there's nothing else to do, so it stops running. In the next lesson, we're actually going to finish this by looking at process standard input and see what it means to create our first asynchronous Node.js script. In the last lesson, we built the first part of the question answer app, which defines the questions, as well as a function to ask or prompt the user for each answer. So in this lesson, we're going to use the process.standardInput object to listen for answers. So I'm going to continue working in the same file. The first thing I'm going to do down here is wire up a listener using process standard input. And we're going to use the on function to listen for events. The event name that we're listening for is a data event. That means that you've typed something into the keyboard and you've pressed enter. And the second argument of the on function is the handler, or the function that we will use to handle that event. So I can collect your data as the first argument that's sent back to this callback function and do something with it. For right now, we'll just echo it back to the user using process.outWrite. And we'll write a couple new lines. And then we'll take the data, which is currently passed to this function as a buffer or a binary. So we have to call .toString on it. And then I'm also going to trim it so we get rid of any leading and trailing spaces or commands. And I'll go ahead and write a couple other new lines. So what we've done here is we've used the process.standard input object to listen for data events. We've also created our first asynchronous application. So because this application is listening for input data, the application will be open and running. And every time we type in some data, we will see it in the terminal. Let's take a look at this. I'm going to open up the terminal. I'll move the code here so we can look at our recent code. And node questions. So here we can see what's your name, and I can type in Alex. And notice the program still hasn't exited. So because we've wired up this data event, the program's going to continue running and continue listening for data. So every time I type anything, and we see it echoed back to the terminal. So for this type of process, I'm going to have to stop it by issuing a Control-C. And I'm going to come back up here to my code, and I'm just going to add one line after we collect your answer. And this line will be process.exit. So using the process, I'm going to invoke an exit event. Let's go ahead and see what happens. Come back down here to the terminal. I'll clear it out. Node question. What's my name? Alex. It's echoed back. And because we invoked a process exit on line 16, the program exits and we're back to the start prompt of the terminal. Great. So now that we understand how the process.standard input object works, let's complete our Q&A app. So instead of taking your data and just echoing it back to you, what I'm going to do is copy this data to string trim call. And I'm just going to add this to an array called answers. So first, let's create an array called answers. And then I'm going to go ahead and say answers.push, and we'll go ahead and paste that data to string.trim call. So now I'm going to check the length of the answers array. So if answers.length is less than questions.length, what we want to do is ask the next question. And we can send the index for the next question from answers.length. So that means that if I've answered one question already, then we will ask the second question in the array, because answers.length will be 1, and that index will point to the second question. Otherwise, we have all of the answers, so I'm just going to invoke a process.exit. Let's take a look at what's going to happen here. On line 12, we ask the first question. And when we ask the first question, we don't send any index, so I is equal to 0, which means we ask the first question in the array, what is your name? Now, as soon as I answer that question by typing Alex and pressing enter, this callback function will fire. And we will take that answer, Alex, and push it into the answers array. Now that we have one answer in the array, 1 is actually less than 3, or the length of the questions array. So we're going to use that answers.length, the value of 1, to ask the next question. Inside of the ask function, I becomes 1, and we ask the next question. So we will iterate through all of the questions using this little if-else block right here. The last thing I want to do is handle the process exit. So whenever the process does exit, I can wire up another listener for an exit event. And that listener can be handled with a callback function passed as the second argument. So what I want to do in here is write your answers back to you. Now remember, answers is an array. So the first question was, what is your name? The second question is, what would you rather be doing? And the third question is, what is your preferred programming language? So the first answer is going to be your name. And the second answer is going to be your activity, what you'd rather be doing. And the third answer is going to be your preferred programming language. So using array destructuring, I can set some local variables for name, activity, and language. We haven't talked about this much thus far, but when we use the template string, we actually honor any white space. So if I added new lines inside of this console log, they would show up. I'll print thank you for your answers. So we'll use them like a Mad Lib, and I will say go activity name. You can write lang code later. So now when the process exits, this handler will fire because we added a process on exit listener there on line 25. So let's go ahead and run our application. I'm going to come out to the terminal and make it a little bigger and clear it. And we can run node questions. And the first question is, what is your name? Alex. What would you rather be doing? Skiing. What is your preferred programming language? Node.js. And when we hit enter on that last question, the process exit fires. So we print this message that says, thank you for your answers. And go skiing, Alex. You can write Node.js code later. Finally, notice that the template string that we're using honors whitespace. In the last lesson, we started working with Node.js asynchronously by using event listeners. Another way we can work with Node.js asynchronously is through the timing functions. The timing functions, setTimeout, clearTimeout, setInterval, and clearInterval, work the same way they do in the browser, and they're available to you globally. Let's go ahead and create a 3-second delay using a setTimeout function. I'm going to come over to our folder and add a new JavaScript file called timers.js. And our wait time will equal 3000 milliseconds, which is 3 seconds. So then we will go ahead and log a message using the template string, so using the backtick characters. So in this console log here, we're going to take the wait time and divide it by 1000, which will give us the number of seconds that we're waiting. Now it's time to create a function to invoke when the timer is finished. So when the timer is finished, we will add this arrow function. And because this arrow function is only going to contain one line, I don't have to use the brackets. So we'll do console.log, done. So here is a one-line arrow function that when we invoke it, it will just simply log the term done to the console. So now I'm ready to use the setTimeout. And when you set a timeout, the first argument is the function to invoke when the timer is completed. Timer finished will be that function. The second argument that we're going to use is the time that we should wait for this delay. So I'll go ahead and add the wait time. There we go. So now this process will run asynchronously for 3 seconds. Once we've waited for 3 seconds, the timer finished function will be invoked, and we should see the term done logged to the console. Let's go ahead and open up our terminal and run our application, node timers. And we see our message, and after 3 seconds, we see the term done logged to the console. So far, we've created a small application that uses the setTimeout function to create a 3-second delay. We can improve this application by using the setInterval function to run an interval that intermittently reports on how long we've waited. So in order to get this started, I'm going to come up here to line 1 of our timers.js file, and I'm going to go ahead and add a wait interval. The wait interval will be half a second, so 500 milliseconds. I'm also going to create a variable for the current time. And current time will equal 0. Most of the variables that I declare with const because I don't want users to be able to change their value. However, anytime I want to change the value of a variable, I'll have to declare that variable with let. So the other thing that we're going to do is we are going to create another function here. Now I'll declare the increment time function with an arrow function, but because we have several lines, we're going to use the brackets to enclose those lines. So what we're going to do is take the current time, and we are going to increment it by the wait interval. And then we'll also add a log to the console. Waiting current time divided by 1000 seconds. Great. So I can go ahead and save this. And now the next thing I'm going to go ahead and do is right above my setTimeout here, I'm going to add a setInterval. SetInterval is very similar to setTimeout. The first argument it takes is a function. And the next function is the time that the interval should wait. So we'll use wait interval, which is a half a second. So what happens with setInterval is it will call the increment time function over and over and over again every half second. Let's take a look at this. I'll go ahead and save this file and come out to the terminal and node timers, run our application. And we can see that we started a 3-second delay, but the interval is firing over and over again every half seconds. So we are incrementing the waiting time. Notice there was a done logged to the console after 2.5 seconds. So that's when the application can finish. Because we set an interval and we never cleared it, this process will run indefinitely. So what we have to do is clear the interval. I'm going to hit Control-C to stop the process in the terminal. Clear just to set me up for the next run. And I'll close the terminal for a second. And now I'm going to modify the timer finished function. So the first thing I want to do, if I need to clear the interval, I have to have a variable for the interval. And whenever we set an interval, the setInterval function will actually return the interval itself so that we can clear it later. So when the timer is finished, I'm actually going to do a couple of things. So this is no longer going to be a one-line function. I have to use the brackets so that I can console log that the timer has finished, as well as clear the interval. So now we'll go out to the terminal and run this file. And we see our 3-second delay and our waiting messages. And also notice that when we are done, we clear the interval, so the interval is still not ticking. And because the interval is not ticking, the application exits. So let's go ahead and improve this application by communicating the waiting time as a percentage. So what I'm going to do is close out our terminal, and I'm going to come back up to the increment time function. And I'm going to calculate a percentage. So I'll create a variable that we'll call P. So we're going to use the math.floor method available to us in JavaScript. And we will take the current time and divide it by the wait time. And the reason we're using math.floor is because this number will give us a decimal. And what we want to do is have a percentage. So we're going to multiply the current time divided by the wait time times 100, and then trim off the decimal using math.floor. So now we're actually going to take a little bit more control over the terminal using process standard output. Process standard output, studout, lets us clear the last line. So this will get rid of the last line that we wrote to the terminal. And we can also move the cursor back to the start position. Process studout dot cursor to will move the cursor to any position that we want. So when we put in 0, it will move the cursor back to the start of the line. So now we'll go ahead and write our message using process studout.write, waiting, and we'll go ahead and use our P and put a little % character right after that. Great. So the next thing we're going to do, just to make this a little bit more fun, is instead of waiting for 3 seconds, we'll wait for 5 seconds. So I'm going to go ahead and save our application and open up the terminal, clear the previous output, and node our timers application. So we have a 5-second delay, and notice that we're logging the time that we're waiting as a percentage. So the last thing I'm going to do is just clean up the way this application reports, so we don't have the done jammed against 90%. I can come into the timer finish just before we write done, and I'm going to go ahead and copy the process studout clear line and process studout cursor to 0. So this will clear the last percentage, move the cursor to 0, and we'll see the done right in the terminal on the same line where we were reporting the percentage. So let's go ahead and try this one more time. Open up the terminal, node timers, and we can see our time being communicated as a percentage. And when we're done, we will see the done message and the program will end. Let's just take one quick look at this to recap what we've done. So we have the interval that we've used using setInterval on line 22. The interval is set to call the increment time function that we declared on line 5 every half second. So every half second, we're going to add to the current time and then calculate our percentage using the current time versus the wait time, which is the total time. Using process standard output, we're able to clear the line, move the cursor back to 0, and then overwrite our last percentage with the new value. Once the timer has finished, on line 15, we declare the timer finished function that clears the interval and then removes the last percentage line so that we can write done in its place. In the last chapter, we took a look at the objects and functions that are globally available to you. One of those functions that is globally available to you is the require function, and we used it in the last chapter to load the path module. Let's do that again. Let's go ahead into our exercise files and create a new file called core.js. And within this core.js, I'm going to create a variable called path and require the path module. The require function is what we use to load modules. Now, many of the modules that we load and work with are hosted on NPM and delivered by the community. We'll talk more about NPM and those modules later in the next course. For now, what we're going to focus on in this chapter and the next few chapters are those Node modules that you don't have to install with NPM. These are the modules that are installed locally with your installation of Node.js, and we refer to them as the core modules. The path module is a core module because it came with Node.js. We can use it out of the box. And the path module helps us do a lot of wonderful things. Like for instance, let's say within our exercise file folder, we had a folder called www, and within our www folder, we had another folder called files, and within the files folder, we had another folder called uploads. And if I wanted to create a path to that from my core.js file, I could use the path module to help me out with that task. So I'll go ahead and create a const dir uploads, and this will point to the uploads directory using path.join and __ dir name. That'll give us the full path to the current directory, our start folder. So if I wanted to reference the www files uploads directory, I can just supply those as arguments to the path.join function. And we can go ahead and log the dir uploads to the console so we can take a look at what that will look like. So I'm going to go ahead and open up my terminal, and I'm going to go ahead and also close the files. And from here, let's go ahead and run node core. And you can see the full path to the folder that we're in, chapter 4.1 start. And I also referenced the www files uploads directory, and we joined that all together using the path join function. There are tons of helpful modules that came with your installation of Node.js. So I'm going to load another core module, the utilities module, into a variable called util. And using the require function, I'll load a module named util. And this module has a lot of helper functions that we can use, but specifically they have a log that's a little bit more powerful than the console log. So I can say util.log, and we can take our path and use the base name function. We'll send it the __ file name, and that will give us the current name of the file, but we're going to see this in a utility log. So I'll do another utility log, do a little up caret and say the name of the current file. So let me go ahead and save this, and we can pop open that terminal and run our module again, node core. And you can see that the utilities module logs our strings to the console like the console log would, but with the utilities module, we also get the date. So every log has a date and timestamp associated with it, which might make logging a little bit more official. The primary difference between the utilities module and the console log is that we had to require the utilities module. So here on line 2, we had to load the module before we can use it, and console log we can use out of the box. There are tons of helpful modules. Let's take a look at one more. I'm going to go ahead and load up the V8 module. And for the V8 module, I'll just do a util.log v8.get heap statistics. So the get heap statistics is a function that's available to us on the V8 module. So when I save this and we go ahead and run it, we'll go ahead and take a look at the memory usage and our memory statistics. So we'll do node core. And as you can see, this shows us the total heap size of our menu, the physical size, available size, the heap size limit, and so on and so forth. So there are dozens of modules that we can use to help us build applications within Node.js. And let me show you another little trick that you might come across in Node.js files. All of these functions that we want to use can actually be destructured out of their modules. So for instance, we're using util.log. Well, if I came up here and instead of naming the full variable util, I can just pluck out the log function by destructuring only the variable that I need. The same is true for V8. If I only wanted to use the get heap statistics function, I can do so by destructuring it out of that require statement. So then it might make my code look a little bit better. There are arguments for or against this because at the same time, we might not necessarily know where the log function is coming from or where the get heap statistics function is coming from unless we look at all of our require statements. Let's go ahead and just give this a quick test. Node core, and we still see the same utility log and our heap statistics. So there are more modules that are useful for us to require out of the box. And for the next couple chapters, we're going to focus on these core modules in particular. Readline is a module that we can use to help us build an application that would ask questions of a terminal user. It's an interface around readable and writable streams that allows us to easily write code that would prompt the user and collect their answers. Let's take a look at using the Readline module. I'm going to go ahead and add another file to the directory here, and I'm going to call it ask.js. And within this file, we'll first load the readline module using the require function. And readline is one of those core modules that's available to you without having to install anything other than Node.js. In order to work with readline, we must create an interface. So I'm going to create a variable called rl that we will use as our readline interface, and I can call readline.createInterface. So within the createInterface function, we need to supply an object that tells readline which stream to use for input and which stream to use for output. We're going to use process.studin for input and output process.studout. This means that we can ask questions and collect input from the terminal. So now, to ask a question, we can use the question function that's available to us on our interface. So rl question, how do you like Node? The first argument is the string for the question that we should ask, and the second argument is a callback function for once that question has been answered. The answer will be supplied as an argument to that callback function. So as soon as we get the answer, I'll go ahead and console log your answer, and then we'll go ahead and do answer. So now if I save this and then open up the terminal and node ask, you will notice that our question has been asked of us. How do you like Node? We have an asynchronous process running because we're waiting for my answer before the callback function is invoked. So I can say I love it. And as soon as I hit enter, we will invoke that callback function, and it says your answer, I love it. So this is an example of how a core module will help us write code that's a little bit easier to work with in order to get the job done. In the last lesson, we introduced the readline module, and we saw how we can interact with the terminal using this module instead of using process standard input and process standard output directly. In this lesson, we're going to try to rebuild the question interface that we built in the last chapter, but this time using readline. So the first thing I'm going to do is come over to my files and add a new file, and I'm going to call this questions.js. And the idea is we want to have a variable that can hold our questions, like an array. And within this array, we want to be able to add any number of questions and have those questions asked of the user through the terminal. So we'll go ahead and ask, what is your name? Where do you live? And what are you going to do with Node.js? So sometimes when I have a coding challenge, I try to think about what I do and represent it as a function call. So for instance, I know that we need to collect the answers from the user in the terminal. I'm not necessarily sure how to do that, but I can imagine that there would be a function called collectAnswers. And without knowing how the collectAnswers function will work, what I do know is I want to send it an array of questions. And I want the collectAnswers function to ask every question in the array in the order that they're presented of the user. And when I get a list of answers back, I can handle that with a callback function. So I know that the second argument of my collectAnswers function should probably be a callback function. And that callback function should pass a list of answers back. So I send a list of questions in as an array, and I expect a list of answers back. So let's go ahead and see what I might do with this. So for instance, when we get an answer, I can console log, thank you for your answers. And I can also console log the answers, so we can take a look at that list, and I'll also call process.exit. All right, so this is what I want to do. And at this point, I might not necessarily be sure how to do it, but I know that I need a function called collectAnswers. So I'm going to go ahead and create that function. And the first argument that the collectAnswers function is going to take is an array of questions. So I'll go ahead and call them questions. And the second argument is a callback function to be invoked when we're finished. So I'm going to call this done, meaning I want to invoke this function once the user has answered all of the questions. So we'll create the function body. And what we're going to do is we're going to have an array of answers. And that's an empty array to get us started. But whenever we're done, we're going to invoke that argument, the done argument, and pass the answers back. So once we've received all of the answers, we can send it back to the callback function. I'm just going to go ahead and comment this out because we don't want to do that yet. The first thing we need to do is ask the question and collect the answers. That's where the readline interface is going to help. So I'll come up here and pull in readline, require readline. And I'm going to also create our interface. So const rl equals readline dot create interface. And we are going to use for input process.standardInput, process.studIn, and for output process.studout. And maybe we should spell process correctly. Great, so now we have a readline interface for answering questions. So I'm not really sure what I'd want to do next. I do know I need to ask the first question. And one thing I can do is grab the first question by destructuring it from our array of questions. So if I wanted to, I could get the first question, second question, or third question by destructuring it from the array of questions. So that's how we're able to get the first item in the array, the second item in the array, or the third item in the array. In this case, I only want the first question, so I'm not going to bother with asking for the second or third question. So that would give me, what is your name? And the next thing I know I need to do is I need the ability to ask that question. So I'm going to go ahead and say readline.question, first question. And remember, readline, the first argument is the string, and the second argument is a function that will be invoked once the question is answered. So I'm just going to call this question answered. So here, I'm going to get rid of our little call to done answers on line 18, and I'm going to create this question answered function. So this is the function that readline will invoke once the user has answered the question. So we know this function is going to take in the answer. And what I'm going to go ahead and do with that is push the answer into the answers array. So when the user answers a question, we're going to push that answer directly into our array of answers. And then the next thing we're going to do is check to see if the user has answered all the questions. We can find that out by typing if answers.length is still less than questions.length. Then what we want to do is ask another question. So that means if the length of the answers array doesn't match the length of the questions array, we probably need to ask another question. So I can say rl.question again, and this time we'll find the question from the questions array directly. And in order to know which one, we can use the answers.length. So if I have one answer within my answers array, then I'm going to ask questions1, which would give me the second question within the questions array. Once I have two answers, the answers array will be of length 2, so I'll ask questions2, which will give me the third question. Now, if answers.length is not less than questions.length, that means we have the same number of answers as we do questions, which means that we're finished. So I'm going to go ahead and add else. So we can go ahead and invoke done, and then we can pass all of the answers back to the callback function. All right, great. Let's go ahead and give it a shot. So I'll come over here to the terminal, and we will node questions.js. It says, what is your name? Alex. Where do you live? Tahoe City. What are you going to do with Node.js? Change the world. And we can see the message, thank you for your answers. And then here are my answers. The answer to the first question was Alex. The answer to the second question was Tahoe City. And the answer to the third question was change the world. So let's just do a quick recap. We created a collect answers function that we can just simply send an array of questions and a callback to handle once we have all of the answers. And in this case, we're just saying thank you for your answers and logging the answers array right before we exit. The function itself takes in the questions as the first argument, that's our array of questions, as well as a callback to invoke once we're done. And then we create a new array of answers. On line 27, we use readline to ask the first question, and every other question is asked on line 21. And once we have the question answered, our question answered function will be invoked, and we will add our answer to the answers array. If we don't have all of our answers, we're going to ask another question again, but when we do have all of our answers, we're going to invoke the done callback and pass the answers there. In Node.js, every JavaScript file is its own module. Now we've been loading modules with the require function. The require function is part of the common JS module pattern, but it only represents half the pattern, the half that loads the modules. The other half of the pattern is module.exports, or the mechanism that we use to export data and functionality from a module. Let's take a look. Let's create a new sample file within our files called mymodule.js. And from mymodule.js, I can call module.exports to export any JavaScript type or values. So I'll go ahead and export Alex. And then from another file, I can consume this file with the require function. So if I go into my files, I can create a new file called app.js, and we can consume the value that I exported from my module. With the require function, all we have to do is specify the path to the module. So I'm going to start with a /my_module. Now we don't have to provide the path when we import core Node.js modules or when we import modules that we've installed with npm. But whenever we want to load other JavaScript files that we've created within our file system, we have to provide the path to that module. Let's go ahead and log the name, and I will open up the terminal, and we can run our app. And when we do so, we see that we have exported Alex. The require function that we've invoked on line 1 will export the value of module exports from our other file. Let's go ahead and make more of a tiny example of this. I'm going to go ahead and create a variable called count, and we'll set that equal to 0. And then I'll create a function for incrementing the count. So we'll say ++count, and we'll make a function for decrementing the count. So we'll say -count. Now, within every JavaScript file, all of the variables are scoped to that module. So the files that consume this module won't have access to the count. What we're going to do is create a function for returning the value of the count. getCount will return the current value of our count. Great. And now that I have all three of these functions, I can export them together in an object. Module.exports allows us to export any JavaScript type. So we'll just export an object by using the curly brackets. And then we will also, let me go ahead and collapse the terminal for a minute so we can see all the code at once. So I'm going to export the increment function, the decrement function, and the getCount function. There we go. And I can save this and then go into my app.js file. So we're not going to call the variable name anymore. We're going to call it counter. And I can use those functions that I created in a separate file. Counter.increment, counter.increment, counter.increment. And then we can come down here to our console log and do counter.getCount. Let's go ahead and save this and then open up our terminal and run our app by typing node app. And we can see that we've incremented the count 3 times, and we are able to use the getCount function to return that variable because the count itself is scoped to my module. Now, something else we can do just to make this file a little nicer if we want it, is we can destructure these functions when we invoke the require function. So instead of setting them all to an object called counter, I can just destructure what I need. In this case, we need the increment and the getCount. And we'll also get the decrement and use that once too. So now I don't need to preface everything with the counter. We've just imported the increment function and the decrement function and the getCount function directly. We'll do one decrement. So now we can save this, go to the terminal, and run our app again. And we can see that using that decrement function once changes the count from 3 to 2. So the Node.js module system allows us to separate our functionality into separate files. We consume that functionality with the require function. And what gets returned by the require function is what we've exported with the module exports function. So here I'm looking at my module.js, and notice that the increment, decrement, and getCount function are being exported here, and they are imported with the require function to our app.js file. Remember the collect answers function that we created in lesson 2 of this chapter? I think we added it to the questions.js file. Oh yeah. So here on line 14, we created a function that will collect answers from an array of questions. This is a perfect case for a reusable function, and we should perhaps move it to its own module. So what I'm going to go ahead and do is come over here to my file folder, and I'm going to create a new folder. The second icon here is to create a file folder, and I'm going to call it lib. So what we want to do is add a collect answers function to this lib folder. So we're going to create this module by modifying the code to the questions.js file. So I'm going to come in here and delete that space between the line. We're going to get rid of the questions for now. Instead of naming the function collect answers, what we're going to do is on line 7 call module exports. So we're going to export the function as a module. So our consumers can name it whatever they want, but we're going to call the file collect answers because that's what this function is. Then the last thing I'm going to do is come down here to where we actually use the file and delete that code as well. Great. So now I've reduced my reusable collect answers function to its own module. The next thing I'm going to do is come over here to go to File and then Save As. And I'm going to go ahead and save this file as collect answers.js. And now that I've created my own module, I also want to add this module to the lib folder. So I'm going to go ahead and grab my collect answers over here and just drag it and drop it inside of the lib folder. And I will select yes for move. And now I have a collect answers function within our library folder. So the next thing I want to do is improve the questions.js file to use this module. So I'm going to go into questions.js. And from here, we don't need the readline anymore. We are incorporating the readline into our collect answers module. We also don't need the function anymore. So I'm going to delete this code from line 7 to line 21. And all we need to do is invoke the collect answers function. So the other thing that we're going to need to do is get a collect answers function. Let's go ahead and say const collect answers equals require. And because this module is within my local file system, I have to specify where the file is. So I'm going to start with // and it's inside of the library folder / collect answers. Great. So now I've modified the questions.js file that we created earlier in this chapter by moving collect answers into its own module. Let's go ahead and test it out. So I can open up the terminal. We'll say node questions.js, and it's asking us the questions. My name is Alex. I live in Tahoe City, and I'm going to change the world with Node.js. And as we can see, the functionality of this file is the same, even though we've separated the logic for collect answers into a separate module. We are going to do one little thing to improve this module. And this might seem a little silly, but if we actually grab this function and get rid of it, let's say I were to put it on my clipboard by doing a command X, and I just sent the questions to the collect answers functions. Maybe my users don't want to handle this when it's done. Maybe they just want to ask the questions for some reason. Right now, if I open my terminal and I run node questions.js, we'll say Alex, Tahoe City, and change the world again. But this time I get an error. And I get an error because our callback is not a function, meaning that when we called collect answers, we didn't send a function with our answers, with our questions. So what I want to do is I want to make this done callback optional for my users. And there's a couple of ways I could do this. So this is the callback function here on line 7. And in our last example, we invoked this function without sending a done. So down here on line 16 is where we call it. There's a couple of ways to skip this. I could just put in another if, else statement if I wanted to, but what I'm actually going to do is create a default function. By setting done equal to f arrow f, I create a default dummy function that won't break my code. F arrow f doesn't do anything. This function just returns the arguments that are sent to it, but this won't break my code. So when we get down to line 16, if done isn't supplied, our code will not break. So we can go ahead and save this, open up the terminal again, and try this out one more time. So I'll go ahead and clear, and then we will node questions, Alex, Tahoe City, change the world. And this time, even though we didn't exit the process when we're done, we're actually still waiting for more responses from the terminal. We made done optional, so we don't see an error there. I can stop the process by hitting Control-C. And just for the fun of it, I'm going to come back into questions, and I'm going to go ahead and paste my handler function in there again, so that we do stop the process and say thank you for your answers. But now we've clearly made that second argument optional, meaning that our collect answers function still works without the callback. A powerful tool that ships with Node.js is the EventEmitter. The EventEmitter is Node.js's implementation of the pub/sub design pattern, and it gives us a mechanism for emitting custom events and wiring up listeners and handlers for those events. Let's go ahead and mess around with the EventEmitter by creating a new file within our samples called events.js. And within this new file, the first thing I'm going to do is get our events module. So we will create a new variable called events, and we will require our events module. So I don't need to put a path to this module because it is a core module that comes with Node.js. The next thing I need to do is create an instance of the event emitter. So I'm going to create something called the emitter. And the emitter is going to be a new event emitter. So the events module comes with an event emitter constructor that will construct a new instance of the event emitter that we can use to raise custom events. Well, how do we raise a custom event? We use the emitter's emit function. And the first argument that this function takes is the string name of the event. We can call our events whatever we like, but they should make sense to the user. I'll call this custom event. So here we're going to raise a custom event. The next set of arguments represents the data that I want to pass to the handler of the custom event. So we'll go ahead and pass a hello world and the term computer. And the idea behind this is we're going to say that the computer has said hello world. So the power of the event emitter is we can raise in our code events wherever we like. So I'll raise another custom event, And we'll say that's pretty cool. And we'll say that Alex is the one that said this. Great. So these events are being raised within our code. What we need to do next is handle them. So using the emitters.on function, I can wire up a handler or a function that will handle custom events. So we can say when a custom event occurs, handle it with this callback function. Use a little arrow function here. And within this arrow function, we will take in the argument. So the first argument that is sent to this callback function is the second argument of the emit. So this is our message. And the next argument would be the third argument of the emit function, and so on and so on. So in this case, we only have two arguments. So the message and the user are being passed to the callback handler. And from within the callback handler, we can go ahead and log user : message. Great, so I can save this file, and I'll go ahead and open up the terminal. And we can go ahead and run this by typing node events. And we can see two events have been raised, one on line 9 and one on line 10. Both events are handled by the same handler function that we registered on line 5. So the event emitter gives us a way to raise and handle custom events. One other important feature of the event emitter is that it's asynchronous. These events are raised when they happen. Let's just do a quick example of this by listening for user input from the terminal. So we'll say process.stdin on data. And when we receive that data, it'll be passed to this callback function. So whenever the user types anything, we will collect it here. And I'll create a variable called input where we take the data, convert it to a string, and trim that string. So that's what the user has typed. And we can emitter.emit our custom event. And from this custom event, we can say that the message is the input and that the terminal user is the one who added the message. And we'll go ahead and add one more thing to this function. So we'll do an if statement. If the input happens to be equal to exit, we can do a process.exit. But right before we exit, we can also raise another event. So I can say emitter.emit, another custom event. And this time we can say goodbye from the process. Great. So let's go out to our terminal and run our new example. Say node events. And as you can see, we just have a listener. So we're listening for any data that's input into the terminal. So if I say hello world, we see the terminal has said hello world. If I say Node.js is neat-o, we see that the terminal says Node.js is neat-o. And then when I type exit, we see that we exit the process, but the process says goodbye right before them. So the event emitter gives us a way to raise custom events that we can wire listeners or handlers to using the on function. In this example, every time we hit line 15 or line 12 within this code, a custom event is raised and some data is passed to that event. On line 5, we actually handle all of our custom events by using the on function and retrieving the data that was passed to that event in the callback function. And in our case, we're just displaying that to the user in the terminal. Back in lesson 5 of the current chapter, we took our collectAnswers function and we turned it into a module that we can make reusable. So if you look within your exercise files under the lib folder, there's a collectAnswers.js, and this is our module for the collectAnswers function. We can improve this function by using the event emitter. So I'm going to go ahead and pull in my event emitter by calling const event emitter. Notice this time I'm destructuring the event emitter right when I require our events module. That way I can just use it directly without having to preface it with events . So down here inside of our function, let's go ahead and create an instance of our emitter. So we'll create an emitter equals new event emitter. So we're creating an instance of an event emitter by invoking the constructor function. And then down here at the very end of the function, let's go ahead and return our emitter. So now we can use this emitter to raise events when certain things happen within this function. For example, let's say we wanted to raise an event every time the user answered a question. Well, whenever the users answer a question, this question answered function gets fired. So right before we push the answer in the array, I can call emitter.emit, and we can emit an answer event. So we'll go ahead and emit event, and we can push the answer that was returned. Great, so I can go ahead and save this. Now every time the user answers the question, we're raising an event. Let's also raise one more event. Down here where we say done and use the callback, let's go ahead and emit a complete event. And when we emit the complete event, we will go ahead and pass all of the answers. This just provides an additional option for our consumer to listen to complete events. Great, so we've improved our function. Let's go ahead and save this and come out to our consumer module, which is the questions.js. And the first thing that we should notice is if we actually open up the terminal and I run this file, it still works. So we can see that everything still works. We've just improved this function by providing some options. And those options are to wire up listeners for events. So for instance, I can come in here and collect answers returns an event emitter if we want to use it. So I can say const answer events equal, and then there's our collect answers function. And then I can come in here and say answer events dot on. Whenever there's an answer, we can take that answer and we can just go ahead and log it to the console. And I'll go ahead and collapse the file so we can see the whole thing. And we'll go ahead and add our answer to our question answered. Great. So now whenever there's an answer event, we'll go ahead and add the question answered to the console. So let's go ahead and take a look at this now and see what that change has done. So I'm going to clear the current screen, note our questions, and we say, what is your name? But as soon as I answer the question, I have an additional handler there. And that's because our collect answers function now raises an answer event. So if I say, where do you live? And what do you want to do with Node.js? We're just repeating all of the answers back as they occurred to the user using the event emitter. I can also improve my code by adding a complete event. So we'll say answer events.on, and complete is the event that we'll listen for. And what we want to do within this complete event is I'm going to go ahead and take our callback function here. So we will do this as opposed to using the done function. And I'm just going to go ahead and paste that as the second argument. So when we are completed, we're going to go ahead and get answers. And to show that we can wire up as many of these as we like, I'm going to go ahead and grab that process exit and do another answer event. So this time when we're complete, I'm just going to go ahead and invoke a function that calls a process.exit. There we go. So notice I have two listeners for the complete event. Now when we're finished, we're going to say thank you for your answer and log the answers, but also we are going to exit the process. So let's go ahead and open up our terminal and watch these changes. So I'll go ahead and clear the current stuff from the terminal and say node questions. So now we get what is your name, Alex, question answered, Tahoe, and what are you going to do with Node.js? Change the world. And now we can see that our questions answered, thank you for our answers, and the process has exited. So now we've improved our collect answers function by giving our consumers more options. So they can wire up as many listeners as they want to handle all sorts of events as our user is answering questions. Node.js also ships with a module that allows us to interact with the file system. The FS module can be used to list files and directories, create new files and directories, stream files, watch files, modify file permissions, just about anything you would need to work with files and directories. So first, let's get started by listing the contents of a directory. You will notice within the start folder of the exercise files under Chapter 5, Lesson 1, there's an assets directory. And we have a couple of files within this directory. So let's say we wanted to read the contents of this directory. We would start by creating a new node module called list.js. And notice that I put the list node module on the same level of the assets directory. Within the list.js file, I'm going to go ahead and load the fs module by using the require function. And we're going to require the fs module. Now I can read the contents of a directory into a variable just by invoking fs read dir sync. And then we should supply the path to the directory that we want to read. If we wanted to read the contents of this directory, we could just use /. But since we want to read the contents of the assets directory, we're going to use /assets. Great. I'll go ahead and console log the files, and we'll take a look at this in the terminal. So I'm going to go ahead and open up the terminal, and I will node list. So these are just the three file names of the three files that we have found within the assets directory. Notice the function that we use to read the files, read dir sync. This function is executing synchronously. That means that line 3 is blocking, which means that JavaScript is going to stop everything it's doing until the files within that directory are read before processing any more lines of code. We can exemplify this with a couple of console logs. So I'm going to go ahead and console log started reading files, and I'll go ahead and console log a complete. So now if I come down to the terminal and type node list to run my application, you can see within the console, the first log reads started reading files, and then the files are being read, and then we see the log that reads complete before we dump the file array to the terminal. So there's another way that we can read files, and that is to make line 4 non-blocking by using an asynchronous function, readdir. So readdir will read the files within the directory, but it doesn't set a variable. Once the files within the directory are read, they will be passed to a callback function that we supply as the second argument. The first variable of this callback function is any errors that have been thrown. And then the second variable of this callback function are the files themselves. So I'll use a little arrow function here for this. Now, when the files are read, this callback function will be invoked. Because this operates asynchronously, lines 8 and 10 will actually be executed before the files are read. So if we wanted to print these details to the user when the files are read, we'd actually have to take these lines and place them within the callback function. The last thing that we need to do are handle any errors that might have occurred asynchronously. So we can do this simply by checking the error variable. If it exists, we'll just go ahead and throw the error. And that will stop the processing of our Node.js module. Great. So let's come down here to the terminal. I'll move it down so that we can see the code. Clear the screen, and now run our list. So now the output is the same, except we are doing this asynchronously. We have started reading the files, and then once the files are read, we print a complete message and dump that file array to the console within the callback function. To further exemplify this, I'm just going to go ahead and take this console log and place it down here on line 11. When we run this, you're going to notice the same output. So if I node list, we still see started reading the files, and then complete in the file array after the files are read. But notice that we make the call to read directory before we print to the console started reading files. That's because the callback function is going to operate asynchronously, and it will be invoked once we have successfully completed the reading of the directory. We can also use the fs module to read the contents of a file. Let's go into our start folder and create a new file called readfile.js. And within the readfile.js, we're also going to use the fs module. So the first thing I'm going to do is require that module. And then I'm going to go ahead and read the text that's located in one of our assets. So I'm going to read the text from the readme.md file. It's just some lorem ipsum text, as we can see here. So I'm going to go back to read file, and I'm going to fs.read file sync. So we're going to do this first synchronously, which means that this is going to be blocking. We're going to wait till we've read the contents of the entire file before executing any more code. So we'll read it in assets/readme.md. The second argument that I want to supply is the encoding of the file. Since this is a text file, we're going to read this as UTF-8. So now I can go ahead and console.log our text, and I can open up our terminal. And we will run this module. So I will node read file. And in doing so, you can see that we just logged the contents of our text file to the terminal. So we read that text into that variable named text. Now this is read file sync, so this is blocking code. We can also use the read file function, which is the asynchronous way of reading files. That means that once the contents of the file have been read, we can pass those contents to a callback function. So again, the first variable of the callback function is error. That will be null if there aren't any errors. And then the second argument is the text that we're actually reading, since we're reading this file as UTF-8. Since the text is going to be passed to this callback once the file has been read, that means that I have to move the console log to within this callback function. And I'll also add another console log. File contents read. Great. So let's go ahead and go down to our terminal. I'm going to clear the screen by typing clear. If you're using DOS, you could type CLS, and then we will node read file, and we see the same results. Now this is how we read a text file. We could also read binary files. So instead of reading the readme file using this function, I'm going to go into my assets, and I am going to read the alex.jpg. Alex.jpg is an image. This file isn't encoded as text, so I'm going to get rid of the UTF-8. And instead of calling this text here, I'm going to call it the actual image, because we're going to be reading the binary file. All right. So the biggest difference in reading binary files is we do not supply the encoding argument. So I got rid of UTF-8, and let's go ahead and take a look at the contents of this file. Node read file. And as we can see, the contents of that file have been read into a buffer, and that's our binary. So that is our actual image file, that is alex.jpg. The last thing that we want to do is just make sure we handle errors appropriately. So if any errors occur, we'll go ahead and console log an error has occurred, and we'll go ahead and put the error message out there. Great. Right before we call process.exit. Excellent. So this shows us that we have a little flexibility around handling errors. In this case, we're just going to log the error message and then exit the process. So since I've added a little bit of error handling, let's go ahead and test it out. Let's try and read a file called alex.jpeg. It doesn't exist. So I'm going to save this in node read file. And we can see that an error has occurred. There's no such file or directory as alex.jpeg. So again, we can read text or binary files. If we want to read a binary file, we do not supply the encoding. And we read the contents of that binary file into a Node.js type that we call the buffer. So the file system module can also be used to create new files and write data to files. In this lesson, we're going to take a look at the write file method that's provided with the file system module. I'm going to come over here to my start folder and create a new file called write file.js. And within the write file.js, the first thing we're going to do is require the file system. So we're going to require our fs module. And then the next thing we're going to need is some text. We will write some text to a file. So I'll just go ahead and create some markdown text using a template string so that we honor the white space. And we'll say this is a new file. So we can write text to a file with fs write file. So far we have learned fs.readdir, fs.read file, and now we're going to learn fs.write file. So I'll just jot these down as notes within our markdown. So let's say I wanted to write this to a new file. I'll just use fs.write file. And we can do this asynchronously. There is a write file sync function that you can use if you wanted to write this file synchronously. And then we need to supply the file path. So we are going to write to assets/notes.md. The second argument of write file is the text that we want to use. So I'll just take our markdown and I will trim it just to get rid of those leading and trailing spaces. The third argument is a callback function, which will be invoked once the notes.md file has been created and the contents have been written to that file. Now this function will only take in an error as an argument because there's no data to pass back to this callback. So again, if any errors occur, I'll handle this a little more simply this time by throwing the errors. And that will cause Node.js to stop processing, and we'll see that error in the terminal if it occurs. I'm going to go ahead and console log file saved. Great. So let's go ahead and save this and then open up our terminal and give it a run. Node write file. And when we do this, we see that it says file saved. If I go and look within the assets directory, we should see a new file. There's a file called notes.md. And when I open it up, we can see the contents that we have written to that file. We can also create directories with the fs module. Let's go into our start files and create a new file called directory.js. And again, the first thing we're going to do in this file is require our fs module. And I can make a directory by calling fs.mkdir. The first argument would be the name of the directory that I would like to create. We'll call it storage files. And then because we're using the asynchronous version of the make directory function, our callback handler will only accept an error if it has occurred. So if there is an error, I'm going to go ahead and throw the error. Otherwise, I will console log directory created. Great, let's go ahead and save this and come out to the terminal. And we can run our new directory module. And we can see it says directory created. And notice we have up here storage files. What happens when I run this module a second time? Well, then we get an error, because the storage files directory already exists. So the file system also has a function that we can use to check to see if our directory exists first. So I will call if fs exists sync, and then we'll go ahead and put the name of the directory. So if this function returns true, then the directory already exists. If it's false, the directory does not exist. So we can go ahead and take our make directory call and cut that and put it within this else block. There we go. Now first we're going to check to see if the storage files directory exists. If it does, we'll just log already there to the console. Otherwise, if it doesn't exist, we can go ahead and use our make dir call to create the directory. Let me go ahead and open up the terminal. And now we can clear the screen in node directory. And it says that the directory is already there. So let's go ahead and remove the directory and then run our script again. This time it says directory created. You can also use the fs module to append files. Let's go into our start folder and make a brand new file called append.js. Now, one of the things that I want to point out is if you look in your assets folder, you'll notice a colors.json document. If I look at this document, it's just a JSON object that has some values, including a description and a color list. So we don't need to use the file system to read JSON documents. I can go directly into my Append.js and import this data simply by requiring it. I'll call it color data. And then I'm going to go ahead and require .assets/colors.json. And then within this color data file, I can actually use this information. So I can say color data.color list. And the color data.color list should give us this array, this list of colors. So what I'm going to do is loop through the array using for each. And then we send a callback function to the for each function. And the C is going to refer to each of these colors. So this for each is actually going to loop through each color, and it's going to set C to a different color object every time we iterate through the loop. So from there, I'm just going to go ahead and append these colors to our notes file. So let's go ahead and go up to the first line and include the file system by requiring it. So now within this for each callback, what we're going to go ahead and do is call fs append file. The file that we want to append is going to be in the storage files directory. And we are also going to call that file colors.md. So that's the name of the file that we want to append. Notice that that file is not there at present. So the fs.append file will create the file if it doesn't exist and append to already existing files. So what we're going to append is the color. I'm actually going to use backticks, and I'm going to select c.name. And if I look at the JSON data, c.name should give me each color name, red, green, or blue. And I'm going to also use the c.hex on the other side of a semicolon. And then I'm just going to follow that with a /n so that we get a new line. Great. So let me go ahead and collapse the files out of the code so I can add one more argument to the append file function. And this is the callback that will be called once the append is complete. If there are any errors, it will just pass those errors to this callback. And I will check to see if we have an error. And if we do, I will throw it. All right. So now we loaded some data from a JSON file using the require statement. And then we looped through each of the colors in that data, and we should append a file found in the storage files directory called colors.md. Let me open up my files again and open up my terminal. And let's go ahead and run this node append. And when I do so, it looks like nothing happens. But if we actually go into the storage files directory, we will notice that there is now a colors.md document. And when I open up, it says undefined, undefined, undefined. So I've obviously made a mistake somewhere. Let me go back to my append.js. And the problem is if I look at the colors.json, it's actually c.color, not c.name. So I accidentally used the wrong variable. So we're not looking for c.name, we're looking for c.color. We can go ahead and save that. And we can call node append again. And we can take a look at the colors.md. Notice that this time the correct color was added to the document. So that's what append does. I can actually drop this file by deleting the colors.md document, and I can run append several times. Every time I run append within the terminal, we have been reading the colors and appending them to the file. So if I look at colors.md, you can see that we have lots of lines of the same red, green, and blue colors. So the file system gives us a way to append files through the append file function. You may need to move, rename, or remove a file. The file system module has methods for that as well. Let's go into our start folder and create a new file called rename.js. The first thing I'm going to do is require the fs module. And the rename method has both a synchronous and an asynchronous version. So fs rename sync is the synchronous version, and I'll use that to rename a file. I'm going to go ahead and rename the colors.json file within my assets folder. So the first argument is the path to the colors.json file. That's the file that I want to rename. And the second argument is going to be the new name. We'll call it color data. There's also a asynchronous version to the rename function. And you can also use the rename function to move files. So I'm going to go ahead and select the assets/notes.md. And I can move that file simply by renaming the path. So /storage files/notes.md. As always with the asynchronous function, the last argument is going to be the callback. So if there are any errors, return to this callback function. I'm just going to go ahead and throw them. Great. So running this code will rename one file and move another file. I'm also going to add a setTimeout. And the first argument of the setTimeout is the function that I want to invoke after 4 seconds. So the second argument is 4,000 milliseconds, which is 4 seconds. So what I want to do is wait 4 seconds, and then after 4 seconds, I'm going to remove a file by calling fs_unlink. Unlink has a synchronous version and an asynchronous version. We'll go ahead and use the synchronous version. And all we need to do is send the file that we would like to remove. So the file that I'm going to go ahead and remove is going to be ./assets alex.jpg. Great. So now when we save this, we're performing 3 file operations. 1, we're renaming the colors.json to color data. 2, we're moving the notes.md into the storage files folder. And 3, we're going to wait 4 seconds and delete alex with an x.jpg. So let's go ahead and open up our terminal. So now I can go ahead and run this. I'll call node rename. And the first thing you notice is the color file is now called color data. We also have a process that ran for 4 seconds. And you can see that alex.jpg disappeared from our assets folder after about 4 seconds. And the third thing we did was move the notes file to the storage files. So we can see that our notes.md from earlier in this chapter has been moved from the assets folder to the storage folder. So the fs module really contains every method that you will need to work competently with your file system. In the last lesson, we used the fs module's rename method to rename and move files. You can use that same method to rename and move directories too. Let's go ahead and create a new file within our start folder called directories.js. And the first thing we'll do is require the fs module. And using the fs.rename sync, I'm going to go ahead and rename the ./storage files to simply ./storage. I can open up my terminal and run this file by typing node directories. And we can see that our storage directory is now simply called storage. Let's go ahead and remove the directory. Now to remove a directory, we need to use fs_rmdir. And we're going to use the asynchronous version of this function. So the directory that we wish to remove is going to be ./storage. And once the removal is complete, any errors will be passed to this callback function. So like always, I'm just going to check the error. And if there is an error, we're going to throw it. Otherwise, I'll go ahead and put a console.log storage directory removed. So let's go ahead and go into our terminal and run this file again. So we will node directories. And notice this time we see an error. We're getting a not empty error. So we can't remove the storage directory because we have some files in there. So before we remove the directory, we need to delete all of the files within that directory. fs_readdir_sync is going to be the synchronous version of the function that will read a directory. So the readdir_sync function is going to give us an array of every file name within the directory. I can simply chain a for each to loop through each item of that array. And each item of that array is going to be a string file name. So we can go ahead and throw in a little callback function to handle each file name. Now using fs_unlink sync, I can go ahead and unlink our ./storage/file name. And this will synchronously unlink or remove every file from the storage directory before we hit line 7, where we make the call to remove the directory. Let's go ahead and open up our terminal and run this code, node directories. So this time we notice that there is no error, and we see that the storage directory and all of the files within the storage directory have been removed. So before we can remove a directory with fsrmdir, we need to make sure that all files within that directory have been moved or removed. In this case, we read all of the files within the storage directory, and we used the unlink sync function to remove them all before deleting that directory. The stream interface provides us with a technique to read and write data. We can use it to read and write data to files, to communicate with the internet, to communicate with other processes. In fact, we've already been using it. We've been using the stream interface to read and write data to and from the terminal. I'm inside of the exercise files under Chapter 5, Lesson 1, within the Start folder, and we're looking at the readstream.js file. This code should look familiar. We're using process.standardInput to listen to data events on the terminal. So let me go ahead and run this file by typing node readstream. And we'll see what's happening. Is this asking us to type something? So we'll type a chunk of text, and it says that I've typed 5 characters of text. If I type hello world, we have 11 characters of text. Process.standardInput is a readable stream. We read the data by listening to data events. The file system also comes with a way to create readable streams. I'm going to come in here to the top of this file and include the fs module. So I'll require fs. And I can create a readable stream with the createReadStream function. The first argument that this function wants is a path to the file that should be read. So within our assets folder, we'll notice that there's a lorem ipsum.md file. This is a huge text file just filled with lorem ipsum text. So we will add the path to that. And we can create binary read streams or text read streams. So if I wanted a text read stream, I would just pass the encoding UTF-8 as the second argument of the createReadStream function. So now we've created a readable stream. Instead of reading this file all at once, we're going to be able to read it bit by bit or chunk by chunk. And we read each of those chunks by listening to data events. So just like process.standardInput is a readable stream that listens to data events, I can go ahead and replace that with our read stream. So now when I open up the terminals, we can go ahead and type node readstream, and you'll notice that we're using the exact same function to read a text file. So this text file is being read bit by bit or chunk by chunk. Reading files with streams causes your Node.js application to use less memory because instead of reading everything all at once and loading it into a buffer, you're reading files bit by bit and chunk by chunk. They give us a lot of control because they raise events. So for instance, we could also say read stream.once and wire up additional handlers to listen for data events. So the very first bit of data, we'll just go ahead and put that on the console. Let me go ahead and open up the terminal again and run our read stream. So you can see that every data event is still being raised. We're still reading all of the chunks of data with the handler that we've created on line 6. But also we're reading the first little bit of data. So we can see here, this is what the first little bit of that lorem ipsum text file looks like. So that's powerful. We can actually add a lot of events to listen for data as it's being read. So streams also raise an end event, and we can use the end event to know that the read stream has completed. So we'll go ahead and open up the terminal now and run our application again. And then we can see that once the stream has finished, we have logged to the console finished reading file. So if we wanted to, we could actually collect all of these little bits of data in each data event. So let's say I created a variable called file text, and we'll set it to a string. And then within this data event down here, I can just basically add up all my little data chunks. So then as we read this data bit by bit, we're reading it into the file text variable. So if I wanted to report on how long the entire file is, I could do so here in the end event. And we can look at the total length of the file by taking a look at the length of that file text variable -1. So let's go ahead and open up the terminal. We can clear the current contents and node read stream one last time. And we see that file text is not defined. That's because I called it file txt. So let's go into line 19 and make that change there. And let's clear the console and try this one last time. So in doing so, we can see that we're reading all of the text bit by bit, but in the end, once we've gathered up all of those bits, we can see how many characters of text that is in total. As a Node.js developer, you will use the stream interface constantly. It's baked into everything that reads and writes data. We've already been using streams, and we will continue to use streams. In the last lesson, we took a look at creating readable file streams. We've also been using writable streams too. The process.standardOutput object is a writable stream. I'm going to go into the start folder and create a new file, and I will call this file writestream. So process.studout is a writable stream, which means it has a write method. And we can use the write method to write data to a writable stream. So if I wrote hello world/in, we can actually take this file and run it in the terminal and type node writestream. And we can see the data hello world has been written to the terminal. So we can actually use the exact same interface to write a file. First thing I'm going to do is include the fs module by requiring it. And I can create writable file streams using the fs.createWriteStream method. And the first argument here is where we're going to write the file. So I'll do this in the assets folder /myfile.txt. And again, the second argument, we're going to create a text writable stream. So we'll say UTF-8 for the encoding. So now we have a writable stream, and we can use this writable file stream just like process standard output. The difference is we are now writing output to a file. So now if I go ahead and save this and open up the terminal and type node writestream, we don't see any output in the terminal. That's because we're no longer writing it using process.studout. Instead, we've created a file stream. So now we have myfile.txt, and that's where the hello world was written. Readable streams are made to work with writable streams. So if I come in here to this write stream, I'm going to go ahead and delete these last two lines of code. And let's go ahead and use the process standard input readable stream. And we'll listen for data events from the terminal. And when we have a data event, what we can do is use the write stream to write that data event to a file. So readable streams are made to work with writable streams. Let's go ahead and run this in the terminal. So this time we're listening for some data. If I type, I am Alex, this is Node.js, and go ahead and take a look at that text file, you'll notice that what I am writing in the terminal is in fact getting written to this text file as I write it. Let's go ahead and further exemplify this by creating a read stream using fs create read stream. And we can go ahead and read that lorem ipsum file. So it's the exact read stream that we created in the last lesson. So instead of using process.standardInput, I can go ahead and just read bits of data from this read stream and then write them to my new file or my write stream. So let's go ahead and do this. I'll come back out to the terminal. I'm going to stop this current app from running by hitting Control-C and typing clear to get rid of the extra output in the terminal. And now when I run node write stream, we see nothing happen, but what we just did was actually copy the file. So if I look at myfile.txt, bit by bit by bit, we were able to copy the lorem ipsum file into my file. So because readable streams are made to work with writable streams, they even have a lot of methods that help you compose them. For instance, I can take the process.studin, which is a readable stream, and pipe it to our write stream. And it sends it to the write stream, which will write it to the myfile.txt file. So let's go ahead and run this. I'll type, hello, my name is Alex. And then we can go ahead and take a look at myfile.txt within our assets folder, and we can see that that data is getting written directly to the file. So this works with all sorts of streams. If I wanted to take the read stream, which is our lorem ipsum read stream, and then pipe it to the write stream, which is a reference to the myfile.txt, we can do that too. So I'll come out here to the terminal and run this one last time. Whoops. And we notice that we are calling readstream.standardInput. That's the read stream, so we can delete the standard input and try it again. Let me save this file and come back out here, clear the terminal, and run it. So nothing happens, except we piped from the lorem ipsum markdown document to the write stream, which is my text, and we essentially copied the file. The writable stream is the counterpart to the readable stream. And just like readable streams, writable streams are everywhere in Node.js. Node.js comes with a child process module, which allows you to execute external processes in your environment. In other words, your Node.js app can run and communicate with other applications within the environment that is hosted. In the next two lessons, we're going to take a look at the two main functions used to create a child process, spawn and execute. So far, we've been running our Node files from our terminal. We're typing into the terminal or DOS command prompt system commands. I'm working on a Mac, so the system commands that I can use are based on Unix and work in a Unix environment. Come over here and add a new file, and this file is going to be called exec.js. And what we're going to do is we're going to take a look at the child process module. So let's first include it. CP will equal require child underscore process. So all of the commands that I've just executed are synchronous. They run once, spit out some data, and then the process ends. So the execute function is for synchronous commands. I can do cp.exec, and then using the execute function, I can -a terminal to this folder dot, and save this, and then go ahead and run that. We execute a command that opens up another instance of the terminal. If the command that we're executing returns data, like a ls command, we can grab that data. So what I'm going to go ahead and do is execute an ls. So if there are any errors, I'm just going to go ahead and throw them. Otherwise, I'm going to log the data. So now if I clear my terminal and run our command node execute, we can actually see a list of the directories and libraries using the ls command. What happens when I add an error? So if I were to change this ls command to lst, well, there is no lst command. So it says lst command not found if I try to run it in the terminal. But what happens when I run this Node.js application? So we can see that there's an error, and we threw that error. The error is printed right here. The command that we tried to execute has failed. That's just the Node.js error. If we wanted to see the error that was returned from the command when we executed it, we can see that by looking at the third argument, which I've entitled std_err. So let's come back out to the terminal. So now if I try to run this file, node.exe, I can see the error that's being returned from bashed, because if I run lst, that's the error that I get. So the execute command I can use to execute any synchronous process. This includes any of our node processes. So I can actually run node read stream, just like I would in the terminal, and we can console log the data that gets returned here. And what you'll notice is this time when I run node execute, it's actually running another Node.js process, readStream. And we actually get to see the data that was returned from that process right here in the terminal. We were able to do all of this with the execute function in the child process module. In the next lesson, we're going to take a look at spawning child processes and how that's different than executing them. In the last lesson, we used the execute function to execute external system commands. In this lesson, we're going to take a look at the spawn function. Now, execute is designed to handle synchronous processes. These are processes that run and close and maybe spit back some data as a one-time event. However, execute is not meant to handle asynchronous processes. This could mean long-running processes, or processes that are waiting for input, or anything that remains open. Consider the app that we built back in Chapter 4, the question app. I have it here within this start folder. So if I type node questions, we are asked 3 questions. What is your name? Alex. Where do you live? Tahoe. And notice this application is running. It's asynchronous. It's waiting for me to add some input before it continues. And once I answer the 3 questions, those questions are displayed back to us in the terminal. So the process collects answers from the terminal, and it remains open while it waits for answers. So we wouldn't want to execute this process. We would want to spawn it. Let's go ahead and create a new file called spawn.js. And from our spawn file, the first thing we're going to do is include our child process by requiring it. And I'll go ahead and get rid of this terminal for a little bit. And what I'm going to do is I'm going to create a question app variable. And we're going to run this question app from this process. So we'll use cp spawn. Now spawn wants to know the command that we're going to spawn. So that's the first thing that we would type. And then all of the additional arguments have to come in as an array. So the next thing that we would type is questions.js. So that will go ahead and run our questions module with Node.js in a separate process. So we can now communicate with this process through standard input and standard output. For instance, I can say question app.stdout.onData. So we're going to use the standard output object of our question app. This means that when our question app spits any data back out to the terminal, we can handle it with this callback function. So we'll go ahead and say console.log from the question app, and we'll go ahead and take a look at the data. So when the question app spits out any data, we'll go ahead and log it to the console. So the other thing we can do is listen for when the question app closes. So when there's a close event, what we're going to go ahead and do is console log question app process exited. Great. So let's go ahead and open up our terminal, and I'll go ahead and make it a little smaller just so we can see the code too. And then we will go ahead and node our spawn module, and we see we have an error. Cannot find module CP. That's because it's not called CP, it's called child underscore process. CP is what I called the instance, so that was a mistake that I made. Let's go ahead and try this again. We'll come down here and type clear, and we'll type node spawn. And in doing so, we'll notice that we have spawned the question app, and the question app is asking the first question. Notice that it hasn't closed. That's because this is an asynchronous app. So it's going to remain open until we provide the 3 answers for the questions. I'm going to go ahead and close this by typing Control-C, and then I'll go ahead and kill this terminal. So we can send data to our spawn process using standard input. I can answer all 3 of the questions at once by using question app.stdin, and the standard input is a writable stream, so I can write the data. So I'll answer the first question with Alex, and I'll just go ahead and copy this line. So we are going to send Alex as the first set of data, Tahoe as the second set of data to answer the second question, and change the world as the third answer. So as you can see, we're spawning a process, and we're communicating with that process through standard input and standard output. So let me go ahead and run our application. And when we do so, you'll notice that the application runs all at once because we're answering all 3 questions at once on lines 5, 6, and 7. So it says, what is your name? Where do you live? It's printing all of this information to the terminal because we're listening for data from our question app and then printing that to the terminal, saying from the question app. And then there are our answers. So the question app has gathered our Alex, Tahoe, and changed the world. We also see that because we've answered all 3 questions, the process has exited. So listening to that close event has caused line 14 to be triggered, and we see that the question app process has exited.